Welcome to your very first class on machine learning. In this video, we are going to explore what AI, machine learning, and deep learning actually mean, not just in theory, but how they are used in real world. This is the first part of a complete machine learning course, so don't worry if you are new. We will take it slow and simple. What is artificial intelligence? Let's begin at the top of hierarchy. Artificial intelligence, AI, refers to any machine that mimics human intelligence. That means it can reason, learn, make decisions, and even understand language. From your assistants like Alexa to AI chatbots to Google Gemini to self driving cars, that's all part of AI. It is the umbrella term under which ML and DL exist. What is machine learning? Machine learning is a subfield of AI. Instead of manually programming every rule, we let the machine learn from data. It identifies patterns, learns from past examples, and then make predictions or decisions without being explicitly told how to do it. For example, spam filters in Gmail or product recommendations on Amazon. That's all ML in action. What is deep learning? Deep learning is a subset of machine learning. It uses neural networks with many layers inspired by the human brain. It shines when you give it large amounts of data like images, audio, or video. Examples: facial recognition on Facebook, speech to text on your phone, or autonomous driving. It is all deep learning. AI versus ML versus DL. Think of it like concentric circles. AI is the largest circle. Inside it is machine learning, and inside ML is deep learning. All deep learning is ML, and all ML is AI, but not all AI is ML, and not all ML is deep learning. This hierarchy is important to understand the scope of what you are learning. Types of machine learning. There are three major types of machine learning: supervised learning, unsupervised learning, reinforcement learning. We'll break down these one by one in next few slides. Supervised machine learning. Supervised learning is like learning with a teacher. We give the machine both input and correct output. For example, this is the email and this is whether it is spam or not. The model learns this relationship and can later predict output for new inputs. Unsupervised learning. In unsupervised learning, there are no answers, just raw data. The model has to figure out patterns and structure by itself, clustering customers based on behavior or grouping products, often bought together. They are unsupervised learning tasks. Reinforcement learning. This is a trial and error learning method. An agent interacts with the environment, receives rewards or penalties based on actions, and learns how to maximize rewards over time. Think of video game AI or how robots learn to walk. That's all reinforcement learning. ML process overview. How does ML work? Step 1. Define your problem. Step 2. Collect and prepare your data. Step 3. Choose an algorithm and train your model. Step 4. Evaluate and tune it. Step 5 is use it in real world predictions and keep improving it. This pipeline will become second nature as we go ahead. Key algorithms in ML. Here are some common ML algorithms. Linear regression for predicting numbers. Logistic regressions for classifications, decision trees and random forest. For tree-based learning, k-nearest neighbor. It is for pattern-based learning. Support vector machines, k-means clustering, naive bias, and more. We will explore many of these in practical lessons. What is a dataset? A dataset is simply a collection of data used to train and test your models. It includes features, the inputs, and sometimes labels, the correct outputs. The better and cleaner your data, the more accurately will your model predict. Training versus testing. We split the dataset into training and testing parts. Training data helps the model learn. Testing data checks how well it is learned. The split helps us avoid a major problem called overfitting. Overfitting versus underfitting. Overfitting happens when your model memorizes the training data. It does well on it but fails on new data. Underfitting means the model hasn't learned the underlying pattern well enough. We always want a balanced model, one that generalizes well. Evaluation metrics. How do we know if our model is good? We use metrics like accuracy, precision, recall, and F1 score for classification tasks. For regression, we use mean squared error or R square error. We will explain each with practical examples in future lessons, so don't worry. Role of Python in ML. Python is most widely used language in ML. It is easy to read, has tons of ML libraries like scikit-learn, pandas, numpy, and is supported by the ML community. We will use Python throughout this course. What are the applications of ML? ML is used everywhere, in healthcare to predict diseases, in finance to detect frauds, in retail for recommendations, and even in education for personalized learning. ML is not the future, it's already here. Real life ML examples. Let's make it more relatable. Netflix knows what you will like next. Google Maps can predict traffic. Amazon shows what you might buy. Bank flags suspicious transactions. These are all machine learning at work. Skills you need to succeed. To become good at ML, you need Python programming, some basic maths, logical thinking, data handling, data cleaning, statistics, linear algebra, all, and a lot of curiosity. Don't you worry, we will build these skills together. What will you learn in this course? What will this course cover? This course is structured step by step. We will start with Python basics, move to ML theory and algorithms, build hands-on projects, explore deep learning, and prepare you for real-world roles. This is your complete beginner to pro track.